Hi, I'm Thomas Smart, and the second edition of my book, Serverless Beyond the Buzzword, was recently published. Now, compared to the first edition, the new book has considerably more content and delves far deeper into the different topics around serverless architecture. Now, this is a series of articles and videos where I walk through each of the new book's chapters, summarizing the content and providing some additional commentary. The first chapter is really intended to establish a basic understanding of at least my definition of serverless. Jargon and technical terms are minimal or at least explained. Serverless is a means to create software that will run on a server fully managed by a cloud provider instead of a server managed by you or your organization. And we should only be paying for actual utilization, not idle time or availability. What it really means is that application teams can focus on service configuration and application code, ensure the business value as opposed to the plumbing. The word serverless is a bit of a misnomer as there are obviously servers involved in storing and running the code. It's called serverless because the developers no longer need to manage, update, or maintain the underlying servers, operating systems, or software. For me to consider a cloud service to be serverless, three characteristics are really needed. First, a significant portion of the service must be managed by the cloud provider, including the operating system, most software, the hardware, of course, and often also many common dependencies. We also expect redundancy, scalability, and to some degree security to be more managed and automated by the cloud provider. Second, we pay only for the actual usage. For example, the number of requests, the amount of storage, or the duration for which a service is actually used. It would not be considered serverless if we had to pay for idle time. Third, some services bill for idle time. However, due to their nature or the use case, they can actually be turned off automatically when not needed and turned back on again automatically when required. Now, this approach helps minimize being billed for idle time and so creates a more serverless experience. However, if doing this compromises the security of the solution in any way or makes it unstable, we would still not consider that serverless. A financial example is also covered in Chapter 1. The example focuses on a low-use application, a registration form that is used 20 times a day. Now, processing the form submission takes 1 second. If we run a small EC2 instance or cloud server hosting this form and its processing, the cost would be roughly $1.11 per day. If we take a serverless approach, the cost would be 0.000067 cents per day, so significantly less. While not synonymous with serverless, microservices are often found in this architecture. Chapter 1 introduces microservices, explaining what they are without getting too technical. So microservices are like mini applications that each handle a specific feature or set of closely related features. Microservices are able to work together to meet an application's complete set of requirements. Microservices are what we call loosely coupled, meaning that they can function independently of each other. If one microservice fails, then the other microservices can still perform their respective tasks. On AWS, microservices will run on the Lambda service. This service takes care of almost everything. You only need to upload your microservice code and configure the integrations and access permissions. Following microservices, Chapter 1 provides a simple architecture example and walks through the different components. Several key aspects of serverless are called out in the design. In the example, the API service, AWS's API gateway, takes care of validating and formatting any user input, and it will protect us from attacks such as SQL injection, so we don't need to develop those capabilities in the microservices. An advantage of microservices is that they are very reusable. A single microservice, such as a generic image processor, can be used by multiple projects and managed centrally like a shared service. Such a shared microservices does not necessarily need access to potentially sensitive specific application resources. An application can pass a task to a microservice, which processes it and returns a result back to the application, which will then store it. Due to the distributed nature of serverless, each microservice can have its own set of unique permissions. For example, a user profile microservice can have exclusive access to a sensitive personal data database. Chapter 1 provides a refreshed version of the key challenges and benefits of serverless that were in the first edition. The challenges that are relevant today include vendor lock-in, finding talent, especially with serverless experience, less control, it's okay to let go, SLAs of latest services, research and try before deploying to production. Latency, definitely far better than 2 years ago, but still something to keep an eye on. Unlimited scaling, without limits, that can be costly. Difficult to estimate operational costs. Cloud management, traditional approaches will not be productive for serverless. Service limits, make sure to read the manual before using a service. And relevant benefits include near zero wastage, same as before, but better. Reduced scope of responsibility, so you can focus on where you can add value. Accurate cost estimation, while difficult, it can be very accurate. Highly reusable, which of course will boost productivity. Better security, so those fine-grained permissions that I mentioned. Naturally supports agility and good DevOps practices. Easier to manage time. There's lots of small projects if you're doing little microservices. Highly scalable and fast, which can be done safely when suitable limits are configured. Significantly lower maintenance costs, actually ideally zero maintenance. And Chapter 1 also delves into the history of serverless, types of suitable projects, some public case studies, and common objections. And that brings us to the end of this chapter. A link to the book and to my blog with all of the chapter articles and videos can be found in the video description. Please connect on LinkedIn, and if you buy the book, please leave a review on Amazon. Thank you.